Okay, good morning, everyone. I'm Erica Emerson. I really appreciate everyone joining this morning. I am going to go ahead and mute everyone just so that we don't have a little background noise, if that's all right, and then we'll have time for questions in the end. I'm the director for 21st Century Software, and I'm joined by Susan Clutter, our executive account manager, and Scott Fagen, our CPO. We're recording this session, so again, I'm going to ask that everyone stay muted whenever you're not speaking, and I will just hand this on over to Scott.
Good morning, everyone, or good afternoon, I guess, if you're further east than me. Thanks for joining. We've decided to start this kind of concept of storage byte, which is a short drop-in on something to do with storage on ZOS and potentially tied in with our products. I thought it was kind of a good way to get us introduced as our company grows a little bit. We've been trying to increase our presence in the market. I'm Scott Fagen. I'm head of products here at 21st Century, and this is our inaugural storage byte. And we're going to talk a little bit about total storage and how it does data set space allocation influencing, and how that can save you some time, effort, and money in your environments. We all good, Erica, with the sound and the muting?
Yes.
Okay, great. So I'll just jump right in. So this is our 25-second advertisement about total storage. It's a systems and storage management product that analyzes the behavior of the workload and the data that your workload uses to perform optimizations that can help reduce the total cost of ownership of your environment. The idea here is to reduce the amount of work that your storage management systems programmers, folks like that, have to do to keep the system up and running, maybe save you a couple dollars on DASD here and there, and a couple dollars on CPU utilization in other places as well. Total storage is a fairly wide-ranging product in terms of the pieces that it has and the parts of the system that it affects. It has many components that gather and analyze data that describe the behavior of the system. Total storage uses this data to help to optimize the system activities in two major areas. First, around the migration of data sets through HSM, which we're not going to talk about today, and optimizing space allocation for data sets, which we will. By using the behavior of your system as a guide, total storage can manage these activities more effectively than a set of installation maintained set of exits or policies that are written at a point in time. And obviously, as the system changes, grows, you add workload, you change workload, then you need to continually reevaluate these exits and policies. Total storage observes the history of your workload and makes accurate predictions that are specific to individual data sets rather than you and your team having to build and maintain policies that manage through classes and naming conventions. So today, we're going to talk about the data set space allocation influence capability of total storage. The key elements in this function are that total storage observes the sizing of data sets after they have been used and watches the trends to predict the needs for future allocations of similar data sets. And total storage does this without the system programmer, storage administrator, application programmer, or workload production specialist having to intervene as jobs are running, or as people are running on TSO, or people are doing dynamic allocations. Total storage is involved automatically through system exits. You don't have to change JCL. You don't have to go after anybody to make changes to their programs. So looking at sort of this diagram of the pieces of total storage, the data set allocation space influence part uses these parts of the product. It gathers up SMF data that describes the allocation, usage, and at the closed state of your data sets. So not when the data set is being created, but after it's been closed, we can observe how much of the data set has been used, how many extents there are, and things like that. There's a set of analytics within the product that are used to take the data and predict the right size of future data sets of similar name and class. And that way, the product helps these allocations adapt to the long-term changes that are going on in the workload and predict the proper sizes of data sets as we move forward into the future. And then this capability at the bottom actually gets in front of your JCL or dynamic allocation calls for new data sets using the analytically based parameters rather than the ones that are specified within the JCL, within your SMS policy or in the program call to SVC 99. And does it all in real time. So the most reasonable question that one would ask at this point is, why should I want to influence data set allocation at all? And so I'd answer that question with a couple of other questions. First, do you have people on your teams that have the free time to capture and interpret all the data from the system that would help you to understand how accurate your JCL writers are, your applications programmers are, your production specialists are? Second, do you have the process flexibility to be able to make the changes that are necessary over time as the system changes? It becomes a question of how quickly and frequently can you make these changes, even if you've got the people figuring out all the right sizes. And then three, right, is this really worth all their time and effort to have this be done by people at all? And since you have the product, I expect that the answer to at least one, if not all of these questions is no. So let's just take a quick look at why getting your data set allocations right can and will make a difference in your system. The first big issue is over-allocation, right? I've been a developer for 30 plus years at this point, and I'm generally flummoxed by what's the right answer to doing an allocation anyway. So what I typically do, and I have a feeling that most developers do, is you ask for as much as you think you can get, which, because you want your job to run, right? You don't want JCL to, you don't want the job to fail in the middle. You don't have to keep messing around with your JCL to get it right. So you'll go off and figure out what you're permitted to and always ask for the maximum so that the job runs. This is not a big deal for the individual program or individual application, but it is a big problem for the overall system because now you'll wind up with storage pools filled up with data sets that are full of gas, right, unused space. And this fills up the storage on your, on your volumes, and you're going to run out of space, and then you either have to figure out a way to go and get it all back, or start to monkey around with your allocations to then, within your SMS definitions or your JCL to be able to get this right. It's also important to understand that even with modern storage arrays, they have the concept of thin provisioning, which is kind of a hardware strategy that defers the actual assignment of physical disk space until that space is actually written to. So if I allocate, let's say I have a 27 gigabyte volume, and I allocate a 15 gigabyte data set on it, but I only use 10 gigabytes of that data set space. While there is only 10 gigabytes of spinning round and brown, or in the modern cases, flash storage that's actually being populated, there's still only 12 of that 27 gigabytes left on the volume available for other data sets to be allocated on, even though I've only written to 10. And that's because the structures within the volume itself believe that the data set is 15 gigabytes of space in that volume. Second problem is under allocation. And under allocation in the worst case will cause the job to fail, right? You need more space, and there's just no space there to get. But also what will happen in lesser cases is that the data set will expand into multiple extents. Every time you need to leap around an extent, you're going to use some more CPU to go back and forth. It incurs additional I/O because the system has to tie the pieces of the data set together, whether on the same volume or across multiple volumes, And of course, you're still going to have gas in the last extent that will not be used. And then finally, so I don't, long before I came to either IBM or this industry, IBM had added this capability of release processing. And this can be done through JCL or through another product that scans through your data sets looking for gas to release from them. While this does net some gains in efficiency, it does leave some fairly big problems on the table. First problem is that the space is released back to the system after the data set has been closed. And if it's done by a third-party product, it could be minutes, hours, days after the data set's been closed. So all of that red space here remains until such time as the release is processed, right? This could create the situation where if you're running enough concurrent jobs and concurrent allocations, that you may not actually have the right amount of space available to run multiple jobs at the same time, and some jobs, and it's unpredictable which ones, will fail because the initial extent of a new data set might not be allocatable given the current state of allocations within the storage pool. After that, when you've gone through and released the gas from these data sets, you're going to leave gaps in between the data sets, which may or may not be large enough to service future allocations, thus causing fragmentation on volumes. This will lead for the need to go and defragment these volumes, and which of course creates yet another problem, which means that the data set, the volume itself and the data sets are unavailable while the defragmentation process is moving them around. So how do we do this? We watch the allocations of all your data sets, and we watch what the job requested, and we watch what the actual value of the amount of storage that was used at the end of the job after the data set's been closed. And we keep that in a table in memory. Well, you create a table on disk, we put that table in memory, and when new data sets come along, we take a look at what we believe that the size of the data set should be, which has been calculated by looking at the size of those data sets over time, and we'll override the size that you've specified in JCL or that's been specified to dynamic allocation. You can even use this functionality to override specifications by your TSO users as well. That's an option. The analytics correct, will calculate the right size, and this right size, as I said before, will adjust to changes as the system, or as the workload in the system changes, right? So if some of your batch workflows start to process more and more data, the sizes of the newer data sets will be larger over time. And this works for subsequent instances of GDGs as well as regular data sets. So using total storage and allowing it to influence your initial data set allocations, the system can become far more efficient using less storage, CPU, and time to manage your data sets. All right, so these are, again, just a recapitulation of the problems that you're solving. Right, so now you get out of the business of your application programmers or other people who may or may not have the best information trying to determine the right size, whether that's applications, production management, storage management. Second problem being that your JCL and SMS aren't really dynamic. I've not seen very many people who've written highly adaptive SMS rules, or certainly not very easy to do that in JCL, which gets you out of the I have to go and go through change control every so often to change this JCL or to change my SMS rules. And then again, right, if you get the data set right the first time, you don't have to worry about over allocating and releasing the gas and causing slowdowns in production workload or making data sets unavailable for periods of time when you might need them. The setup is simple. I'm not going to go into the deep details, but for the product to do this, the SMF collection piece needs to be running. You take that SMF data that you've collected over time and you run the analytic process, install the system exits. The total storage operates, and it's kind of its hands and fingers into the system are done through system exits, and start up the ISSMS address space. And then the product just goes off and does what it needs to do. And to see what it has done, there will be a number of IPK messages in all the job logs where the allocations of data sets have been affected. So that is the end of my storage byte, and I think we can open it up for questions here, Erica.
I have unmuted everyone, so you can all go ahead and ask questions if you have any.
And for the things that I can't answer, we have Dave Corwin, who's the lead developer on the product, and I may defer the more technical questions to him.
Jim Barron, Windstream. Hi. Data sets analysis is how long a period is overviewed to make these assessments. For example, we have data sets that are created regularly, let's say 5 or 6 days a week, every week. They are, very large data sets, and every period, maybe a couple of times a month, they're reduced to 0. So the data set's created at 0, and then it's repopulated. How would this tool look at something like that? Repopulated in the sense that when they're created new, they're continuing to create new every day, but one day they, an empty data set is created, and then it's back to large business again.
All right. So then, what you're saying essentially is that I allocate. I'm just going to make up numbers just to illustrate. But so the first day is a gigabyte. The second day is 2 gigabytes. The third day is 3 gigabytes. And then the fourth day it might be 0.
Correct.
Okay. Well, we need minimally to do any kind of influence. We need at least three instances before, like, what is it? One's an event, 2 is a coincidence, and 3 times is a pattern. The net is that we need at least 3 samples to be able to make a determination. And in that case, right, we're going to look at the samples. We're going to see the 1, 2, 3, and the 0, and we're going to profile that without giving away the internals of the algorithm. We will profile that to be 3 at this point in time. And then over time, right, even if you go back and now you do the next week, say 4, 5, 6, and 0, we will then profile to 6. Does that make sense?
Yes.
Okay, so the idea here is we need to, and it's kind of unfair to try to do it with such a small sample, but my head isn't big enough to put thousands of numbers in. But over time, we'll note the trend, and we'll make sure that the subsequent ones are large enough to defeat the trend. Okay?
Yep.
Cool. Thank you.
Any other questions?
For those of you who might be too shy to ask a question, that's fine. My email address is on a subsequent slide. You can certainly send it. And I'm sure that there are probably some questions that are too complicated for the remaining 5 to 10 minutes to try to answer anyway. So that's fine as well.
You have a copy of this slide?
We will distribute the entire slide deck after the webcast is over.
Great.
Hey, Dave. Hello.
Hi, Len.
How does total storage work with an X37 product? Does it jump in before or after the allocations are done?
Jumps in before. Yeah.
So it would be like a replacement of that software? We wouldn't need it anymore?
There are,
Well,
I mean, there are situations where a Stop 37 product are going to be able to do things that we can't do.
I wouldn't say it'd be a total replacement, but for some applications, maybe that would be a yes. But for our entire shop, no, it's way too big, and our CRM people would be over here screaming at me.
Yeah, no matter what, right? Even if we're profiling things and our profile is perfect, there are going to be situations where you could still run out of storage in a data set, and then that's kind of within your bailiwick to decide if you want to pay for something that solves those problems. Right? Our product tends to solve the issue of, you know, wildly variant allocations, trying to make sure that you're not, you know, you're not allowing people to go crazy on the large side or crazy on the low side, and not have to worry about, you know, long-term changes in the size of things. But there are always going to be the aberrant situations where, you know, things don't meet the profile. Right? Analytics are never perfect. They're just as good as they can be. And, you know, so that the concept of a Stop X37 kind of product is really to jump in when a problem is being detected as opposed to trying to prevent a problem. We do the best we can to prevent those sort of problems, but other products go in and actually act on the problem just before it gets exposed to the end user. So that is neither a disparagement nor an encouragement of the other products.
Scott, this is Scott Berry. Can you hear me?
Hey, Scott. Yeah, you're fine. Good.
There's no background noise? I'm sorry about that if there's an echo.
Nope, we're good.
How about, there's a lot of wealth of data that you're collecting, and is there any batch analysis to identify also for cost savings, ZEDC candidate analysis or tape versus DASD analysis or striping maybe based on the data that you're collecting?
So you're speaking about other functions in the product, some of which are there, some of which are planned. So you're right. I mean, I'm narrowly construing just part of the product and the value point, and you've kind of given us some ideas right there for future discussions. But
that works for me. Yeah, that's at least
okay.
it's either on the on somebody's radar or at least or already within the product. That's perfect, because especially with the ZEDC candidate analysis, there's a wealth of SMF metrics that I would believe you're capturing, and then harvesting that data probably in a batch mode, I think would be a better suited analysis, but that's your call.
Yeah, I could throw out something that we don't do, but would be, you know, along those lines, right? You folks have data sets, you know, by the thousands, if not millions, out there that are probably candidates for encryption. And, you know, if we look at the HSM side of our product, we can predict when a data set is not going to be in use by a job, and that would be a great candidate time to go from being a standard format, not encrypted, to being converted to a extended format encrypted data set, right? And use the windows of time when we know the data set's not being used. And those are the kinds of things that, you're right, we have lots of data, and we can use that to our customers' advantage.
Great. The only other question was, again, with a wealth of information here, is there any opportunity for, you don't really have in ZOS a way to establish quotas within a given storage pool, and I'm curious if there's like organizational quotas based on the user ID or some other information about the user. Is there any thoughts about being able to track and then restrict access or allocations based on some essence of quota type?
There's nothing in the product at this time but I'd certainly like to have an offline conversation with you and Dave to talk about, to get a little bit deeper into what you think that would do for a customer and the value that it would bring. Sounds intriguing.
Okay, great. Make that happen. Thank you.
Yeah, thank you.
All right. Any other questions?
Guess I'll take my chance one more time. As far as the ICE SMS started task, what have you observed in terms of overhead? Because everybody's monitoring things like DFHSM overhead or FDR monitoring overhead, and I'm curious about this started task and any percentage of overhead curiosity estimate.
Yeah, so let me put it to you this way. The address space itself and the started task is not very active. We need an address space to anchor things, so that's what it's really there for. And it tends to get activated when you're making changes to the product, as opposed to running all the time and looking at things. So in the, again, so to narrowly construe the answer for the allocation perspective, there's no overhead that's generated by the address space. The code that's being executed as part of the operating system makes a pass through the address space to get some information.
Okay, but there are exits similar to like StopX37. There's a lot of influence of exits, and that seems to be where activity occurs.
Yeah, you wouldn't. Yeah, so here's the thing, right? I'm a longtime IBM guy, CA guy, and now I'm a 21st Century guy. When I was at IBM, I tried to make sure that the billing went off to the other ISVs, and then when I was at CA, I tried to make sure that the billing went back off to IBM. So this is a product that tends to where there's an increase in CPU utilization, it'll tend to be more in, as operating system overhead than seeing it show up in the ICE SMS address space. There will be some overhead for other parts of the product because we do rack and stack things for later processing, but not in the allocation part.
Thank you.
Thank you, Scott.
All right.
Well, then I would like to thank everybody for joining. Hopefully this was useful and successful, and I wish everybody a great holiday season. And so, like I said, these will go out immediately following the session. And I guess I was supposed to say coming soon, we're going to have another session at the end of next month.
Great. And we do definitely appreciate you all joining. Have wonderful holidays, and we will see you next year. Thank you.
Yeah, thank you.